All right, we're doing Algebra 2 Final Review Part 4. Okay. All right, so number 1 here, determine if the sequence is arithmetic, geometric, or neither. Okay, now, if it's arithmetic, it's adding by some number every time. If it's geometric, it's multiplying by a number every time. All right, so on this 3, 8, this looks like it adds 5 every time. 3 plus 5 is 8, 8 plus 5 is 13, 13 plus 5 is 18. It's adding every time, so this is arithmetic because it's adding. Now it could subtract, and over here, this could divide, but mainly it's adding and multiplying. So that's what arithmetic is. All right, number 2, is this arithmetic, geometric, or neither? All right, 2, 8, 32. All right, the way you can tell is how they get real big real fast. This is multiplying. In fact, I think 2 times 4 is 8, times 4 is 32, times 4. This is multiplying by 4. It's geometric because it's multiplying. Arithmetic is adding, subtracting. Multiplying, dividing is geometric. Okay. Now, number 3, find the common difference. All right, so basically, how much does this go up each time? It looks like it goes up 7. 10 plus 7, 17 plus 7. So the common difference, D, is 7. That's the common difference, 7. Okay. Number 4, write the first n terms of the given the arithmetic sequence for the indicated value of n. It says n is 5, so it wants the first 5 terms. Okay, well, here's the first term right there, 7. See, a sub 1, that's the first term. And then D is 4, which means it's going to go up 4 each time. So if I add 4 to 7, I get 11. If I add 4 to 11, I get 15. If I add 4 to 15, I get 19. Add 4 there, I get 23. And there's my first 5 terms. Okay, so there's my first term. That's what the difference is, how much it goes up each time, and that's how many terms I need in. Okay. Now, number 5. Find the 40th term of the sequence. Here's the first, second, third, fourth. What's the 40th? Now, it's adding 6 each time, so D is 6. And you could just keep adding 6 till you get to the 40th number, but you could use the equation. A sub n equals a sub 1 plus D times n minus 1. And you can find the nth number by doing this. Well, the nth number is the 40th number. I want the 40th number, so that means a sub 40 is going to equal a sub 1, which that's the first number, 8, plus my D. Well, as we said, D was 6. It goes up 6 each time. And then I want 40 minus 1. And I'll just punch it in the calculator. So let's do this. Okay. I'm trying to get it in here so you can see the screen. 8 plus 6 and then 40 minus 1 in parentheses. 242. Okay. There you go. That's the 40th number. What about this? Find the sum of the first n terms of the following arithmetic sequence. All right, we want the sum of the first 7 terms. You see, n is 7, so we want the first 7 terms. Okay? All right, so to do that, you got to do this formula. S sub n equals n divided by 2 times a sub 1 plus a sub n. Okay? So the sum of these 7 terms is going to be 7 divided by 2 times the first term, which it says right there is negative 5, plus the 7th term, which we don't have that. So what we're going to do is we're going to go back to this formula to find the 7th term. So we're going to use this formula right here. So a sub 7 equals a sub 1, which is negative 5. That's supposed to be a sub 1 right there. Plus my D, and my D is 4. And then I want 7 minus 1. I'm just using this formula right here. And that's going to give me the 7th term. So it's going to be 19. I just did it in my head. You just punch this in. So this is the 19th term. And now I can multiply this up. So if I do that, 7 divided by 2 times, and then in parentheses, I've got -5 plus 19, and that's going to be 49. Okay, so the sum of the first 7 terms is 49. Now, what you can do is you could write out what all 7 terms are. If -5 is the first one, it goes up 4. That means -1's the next one. 3 would be the next one after that. 7, 11, I'm just adding 4 each time. 15, and 19. There's my terms. If I add these up, -6, -3, 4, 15, 30, 49. It adds up to 49. Okay, so that shows how the formula works. It does work every time. But this right here is sum. This is sum of the n terms. This formula here is a sub n. It tells you what the nth term is. Okay, so you use these two formulas in conjunction with each other. All right, let's go to number 7. Number 7, evaluate this sum. Now what this is, now this actually didn't type up right. It's supposed to be j equals 1 on the bottom and 8 is supposed to be on the top. It didn't type out correctly. So we want to evaluate this sum. Okay, well this is arithmetic. So it's going to be s sub n equals n divided by 2 times a sub 1 plus a sub n. Okay, so if you go from 1 to 8, that's 8 terms, so n is 8. I want the sum of these 8 terms. It's going to be 8 divided by 2. From 1 to 8 is 8. The first term, well, if I put 1 in there, 4 times 1, so I'm putting 1 in, 4 times 1 minus 3 is going to be 1. 4 times 1 is 1. 4 times 1 is 4, minus 3 is 1. Plus the nth term, well, that's when I put 8 in. So if I put 8 in there, 4 times 8 minus 3. 4 times 8 is 32, minus 3 is 29. And now I do this right here. So I just punch this in. 8 divided by 2 times 1 plus 29, and I get 120. And that's the sum of the 8 terms here. Okay. Now, number 8 here. Find the 12th number of the sequence. All right, if you notice, now this is geometric. Okay. So in geometric, we have this right here. A sub n equals a sub 1 times r to the n minus 1 power. This is the formula for a geometric sequence. We want the 12th number, so I want a sub 12 equals a sub 1, well there's a sub 1 right there, times my r, and r is how much it multiplies by each time, and it looks like it multiplies by 4. So r is 4, so this is 4. And I want the 12th number, so this is going to be 12 minus 1. Okay, so if I punch this in, -3 times 4 to the 12 minus 1 power. And I get, -125,82912. That's the 12th number. Okay. Which if I just go, here's 1, 2, 3, here's the 4th one. If I take -192 and I multiply by 4, that'd be the 5th one. 6th one, oh, I'm adding. 5th one, 6th one, 7, 8, 9, 10, 11, 12. And look there, get the same number. See that? That's the 12th number in this sequence. This is how you find the 12th number, this formula right here. So maybe write these formulas down so you have them to look at. This says find the sum of the sequence. All right, this is geometric. Now how you can tell it's got a multiplier there and it's to the power of this. See? So that's how you can tell it's geometric. Now again, this is not printed up right. It should be like k equals 1 on the bottom and 6 on the top. It should be like that. Okay. All right, so to find the sum of the geometric sequence, use this formula. That's supposed to be a minus right there. It didn't do very good writing that. Okay. So if I'm going from 1 to 6, that's 6 numbers. So I want the sum of these 6 numbers. So it's going to be on the top 6. I'm sorry, the first one, I put 1 in this. The first one, I put 1 in this. So 4 times -3 to the 1 power would be -12. So this should be -12. Okay. Then I have 1 minus r. Well, this is my r right there. Okay, so this is going to be 1 minus -3 to the n power, which n is 6. Okay, and this is 1 minus r, which is -3, which makes that 1 plus 3. Okay, so that's how I would type it in. Okay, so -12. I have 1 minus, and in parentheses, -3 to the 6th power, parentheses, and then divided by, in parentheses, 1 plus 3. And I get 2184. And that's my answer there. That's the sum of this sequence. Now, you can do this. If I put 1 in, type this in with 1, you get 12. If I put if my r is -3, so 12 times -3 would be -36. So -36 times 3. I'm sorry, that was -12. Wasn't it? This was 1, so it'd be -12. So 2, that'd be positive 36. I did it backwards. Okay. So 36 times -3 would be -108. Times -3 would be 324. Times -3 would be -972. That's 1, 2, 3, 4. There's 5 of them. I need one more. Times -3 would be 2916. Okay, so here's these 6 terms, and if I add those up, I'm going to get this. Okay, I can do it real quick. -12 plus 36 plus -108 plus 324 plus -972 plus 2916. And look at there, you get 2184. All right, but it's easier using a formula. So here's the formula for the sum of geometric sequence. Number 10, find the sum of this sequence. All right, so let me write it out again like it's supposed to be. It's supposed to be k equals 1 down here, 6 up there, and then 4 to the k power. All right, now I'm going to move this down because I'm going to use this formula again because this is geometric. See, it's got the power. K is the power. So from 1 to 6, that's 6 terms. So I want to find the sum of these 6 terms. All right, it's going to be the first term. So if I put 1 in there for k, I get 3 times 4 to the 1 power, which is 12. Then I have 1 minus my r. Well, there's my r right there. That's the r in the parentheses. So it's 1 minus 4 to the n power, which is 6. And then divided by 1 minus 4. Okay, so I'm just using this formula right here and putting the numbers in. All right, so it's going to be 12. And then 1 minus 4 to the 6th power. Close up in parentheses, divide by, and then parentheses again, 1 minus 4. You have to put this in parentheses when you punch it in. And that's going to be 16,380. Okay? But that's the formula. Write these down, these formulas that I've given you in this video, because you'll probably need them. All right, number 11. Rewrite this in logarithmic form. All right, this is an exponent. There's my base right there, 5. So I could write this as a log, which would be base 5. See this base, and that's the base. The base is the same, but these two numbers now switch sides. So 125 will come over here, and 3 will go over there. And that's how you rewrite it as a log. Okay, so again, my base is 5, my base is 5 for the log. And then these two numbers just trade sides. All right, expand this, log base 3 of 15p to the 5. All right, so right here, this is multiplied, which means I could split it up. Log base 3 of 15 plus log base 3 of p to the 5 power. So since I multiply those two, I can split up into 2 logs and add the 2 logs together. Now, one last thing I do, since there's a power here, I can bring that power in front. So this would be fully expanded right here. Bring this 5 out in front as a multiplier. And this is fully expanded right there. All right, so since it's a product, we can split it up into 2 logs with that plus, and then I got the p to the 5, and the 5 can come out in front as a multiplier. All right. 13, solve this. Okay, well, see how we got the variable and the exponent? So what I'm going to do is, I'm going to do log base 14, both sides. I'm going to do log base 14 of both sides, which makes this cancel. Log base 14 of 14 cancels, and I have 7x minus 3. Over here, I got log base 14 of 140. Okay. Now I add 3 to both sides to get rid of the 3, so I have 7x equals, well, I can't add that 3 to this because this is an argument of the log. So I've just got log base 14 of 140 plus 3. And then I can divide both sides by 7. So it's log base 14 of 140 plus 3, all divided by 7, and then I can punch that in. All right, so watch me as I punch this in. I've got log base right here. So log base, that's 14 is my base, and my argument's 140. And then just come outside, I add 3, hit enter, and now divide by 7. And there's my answer right there, 0.69607. Okay, and then you got to round it probably 3 or 4 places. I don't remember what it says on the test or whatever, but if you round it 4 places right there, the 7 makes the 0 go up to a 1, so it'll be 6961 if you round it 4 places. If you round it 3 places, the 0 makes the 6 stay, so it'll be 0.696. So depending on what it says to do. All right, going to 14. All right, solve this. Log of 4x plus log of 8 equals 0. All right, right here, since we're plussing these 2 logs, I can put them together as 1 log. And then these 2 things I would multiply. So 4x times 8 would be 32x. Okay. Now, this is log with no base. Since it has no base, that means it's automatically a 10. So it means I could do 10 to this power equals 10 to that power. And this will cancel. So 32x equals 10 to the 0 power. If you punch that in, it comes out to be 1. And now you can just divide by 32 on both sides, and this will cancel. X equals 1 divided by 32. Which, if I do that, it comes out to 0.03125. Which, if it says round 2 place 03125, if it says round 2 places, the 1 would make the 3 stay. So that would be my answer right there. Okay. Evaluate this one. All right, now you just punch that in the calculator. So just on the calculator here, let me get it going. Math, go up to log base. See, look, I'm hitting the math button right here. There's the math button. If I hit that, this menu comes on, and I'm going up with the up arrow to the bottom, which there's log base right there, log base. My base is 8. See there, my base is 8, so I'm going to put 8 right here. And then my argument is 1 over 4096. So 1 divided by 4096. And it comes out -4. There's my answer. Okay, number 16. solve this. All right, we got log base 4 of this minus log base 4 of 5. All right, well, since we're minusing these, I can join that up into one log, and it's going to be divided. So it's x plus 1 divided by 5. Okay, so since we're minusing these two logs, I can put them together with a division. Minus is division. All right, now what I can do is, since I got the argument has a variable, I could do 4 to this power equals 4 to that power, which makes this cancel off. It makes that cancel off. So I've got x plus 1 over 5 equals 8. Because this canceled off and that canceled off. So I just have this equals this. All right, well, to solve this, I multiply both sides by 5. This will cancel. X plus 1 equals 40. And then minus 1, I get 39. Okay. 8 to the 3x power equals 32. Anytime your variable is in the exponent, you do a log. So here, I'm going to do a log of base 8, both sides. And that makes this cancel. And so it means I have 3x equals log base 8 of 32. And I just divide both sides by 3. Log base 8 of 32 divided by 3. And I can punch that in. So again, we're going to do the math button and go up to log base. So it's going to be base 8 of 32. Okay, there you go. And then divide by 3. And there it is, 0.555. Okay. All right, this says condense this. All right, see it's a minus. So that means I'm going to divide, but now I got multipliers, and I can't condense them when I got these multipliers. So that means this 5 is going to come as an exponent here, so it's going to be natural log of x to the 5 power. And this 4 will come as an exponent there, so it's going to be natural log of w to the 4 power. Okay. And now once the multipliers are gone, now I can condense it to one log. So it's going to be natural log, and then since I'm minusing, I divide these two. So it's going to be x to the 5 divided by w to the 4. And there's what it would be. Okay. Here, evaluate the expression ln e to the 5. Ln and e are inverses. They cancel. It's just 5. Yeah, that's right. ln and e cancel. All right. Number 20. Solve the given equation round to the nearest 10,000th. Okay, well, there's my variable right there, and see it's in the exponent. So I need to get rid of this 12. So I'm minus 12. That'll go away. So 4e to the 3x equals, that's going to be 9. Okay, now I got to divide by that 4. E to the 3x equals 9 divided by 4, which is going to be 2.25. Okay, now, since I've got my variable is in the exponent, I got to do a log, which I have to do natural log because it's base e this time. So I do natural log both times, both sides. And ln e cancel just like the previous problem. So it means I just have 3x equals the natural log of 2.25. And then divide both sides by 3. And x equals this right here. So let me punch it in. Okay. So I have natural log. Here's a natural log button right here. See, ln. Hit that button. 2.25. Close it up. Divide by 3. I get this right here. 0.27031000721. Okay. Now look at what it says here, which is round to the nearest 10,000th. All right. Here's 10,000. 10,000. See how it has 4 zeros? That means the 10,000th has 4 digits. So 1, 2, 3, I'm going to keep those. Does this 1 right here make the 3 go up or stay? Well, it makes it stay. So here's my answer right there. All right. 21. Use the formula for S of n to find the sum of the first 6 terms of the geometric sequence. All right, that's the formula we had just earlier. I'll write it down again. And when you punch this in, you need to put that in parentheses, so I'll go ahead and write it in parentheses. All right, it wants us to find the first 6 terms, so that means n is 6. The first term is 4. My r, look here, it's going up, timesing by 2 each time, so r is 2. So r is 2, and I want the 6th term, so that's a 6. Down here I got 1 minus 2 in parentheses, and there you go. I just typed it in the calculator. So you're just using this formula right here. Write this formula down so you can use it. And you're just putting the things in. This has 6 terms, so n is 6. The first term is the 4. R, this goes up multiplying by 2 each time, so r is 2. And of course, n is 6. And 1 minus 2, so you just put the numbers in. Now type this in the calculator. So when I type it in, I've got 4, 1 minus 2 to the 6th power, close up the parentheses, divide by 1 minus 2. And I get 252. That's the sum of the first 6 terms. Now what you could do, there's 1, 2, 3, 4. If I times it by 2, I get 64. Times that by 2, I get 128. And now just add those up. There's the first 6 terms. You just add those together. That's all you're supposed to be doing. But 4 plus 8 plus 16 plus 32 plus 64 plus 128. And look there, it comes out to 252 again. See there? So there's my answer right there, 252. All right, now we're shifting gears and going to some exponents. So I got all this to the 3rd power, divided by 18b to the 5th power. All right, so on the top here, everything in here is to the 3rd power. So 3 is to the 3rd power, a6 is to the 3rd power, and b is to the 3rd power. So everything inside that parentheses is to the 3rd power. Well, 3 to the 3rd power is 27. A to the 6th 3rd power, well, I multiply these, that's a to the 18. This is b to the 3. Okay. Now I got some simplifying that take place. So right here, 2718. What you can do is 27 divided by 18 and change it to a fraction. That's 3 halves. Okay. Then right here, when I divide these, I just subtract the exponents. So 18 minus 5 would, I'm sorry, that's a. That's a18. It don't, I gotta do this right here. So 3 minus 5 is negative 2, which means it stays in the bottom, positive 2. And so there you go, there's what my answer would be, simplified. Sorry I messed up on that, I circled the wrong thing, but that's an A, not a B. The B's, these two go together. So 3 minus 5 is negative 2, which means it stays in the bottom as a positive 2. Okay. 23. All this is to the 3rd power, so negative 3 is to the 3rd power. A to the 4th is to the 3rd power. B to the 5 is to the 3rd power. All those are to the 3rd power. Which means negative 3 to the 3rd power is negative 27. Multiply those is A12. Multiply those is B15. So there's what I get with the first one. Now in this one, everything there is squared. So A to the 4th is squared. B to the 3rd is squared. All right, right here, I multiply those, so that's going to be A to the 8. Right there, multiply those, it's B to the 6. Okay, now multiply these two. Well, negative 27 times 1 is negative 27. A to the 8 times A to the 12. All right, I add those now. That's going to be 20. And then 15 and 6, I add those, that'd be 21. And there's my final answer. You have 2 rules we're using here. You got to get 2 rules. A to the 5th times A to the 6th, I add those, that's A to the 11th. A to the 5th to the 6th is A to the 30. Got 2 rules here. When we have 2 bases, each with an exponent, you add those. But if I got a base with 2 exponents, I multiply those. So that's right here, see, I multiply those. Right here, I multiply those. because it's a base with 2 exponents. But right here, when I get down to here, when I put these together, that's 2 bases, each with an exponent, so I add them. Okay. Now on this one, the third root of 32 over the third root of 4, since they're the same root, I can just have one big root, third root, 32 divided by 4. What 32 divided by 4? Let me get it on there. So since both these are third root, I could put 1/3 root of 32 over 4. Well, 32 divided by 4 is 8, so that's the third root of 8. And you can punch this in the calculator. If you hit the math button here, you'll see here's a third root right there, number 4. Okay, see that? So do the third root of 8, and look there, it comes out to be 2. Okay, and the last one here, number 25. All right, the fourth root of all this. Well, since the fourth root of all that, we can break it up like we did the other ones earlier. So this is going to be the fourth root of 256, the fourth root of a to the 28, the fourth root of b16. Okay. Now the fourth root of 256, you could type that on the calculator if you hit the math, and then go down, you could do this x root. Okay, so you have to hit 4 first. So 4, and then do that. So there's the fourth root of 256, and that's 4. Okay, this right here is 4. Here's the fourth root of a28. Well, I divide those. 28 divided by 4 is a7. And the fourth root of b16, well, I divide those. 16 divided by 4 is 4. And there's my answer right there. Okay, so that's it. I've done every problem on here, and we're finished. So if you need any help further than this, just contact me. You know my number. Call me anytime. And hope you study up hard and make 100 on this final. Have a good rest of the day. Bye-bye.